Hello students, how are you all? Today's topic is refraction of light. But before discussion of refraction of light, I will give you a task. Like say, take a small jar, a glass jar. Yeah, the jar is made up of glass, and fill it up with water. Fine. Now take a pen and immerse this pen, just half you have to immerse this pen in water. You will notice that it's looking like the pen is broken from here. Let me draw it. This is your glass jar. Fine. And this much water is there. This is complete water. Fine. And what you have done, you have taken your pen. So this is my pen, fine, which I have immersed in water. But you will notice that this pen is not straight. It's not looking straight. It's like it's broken from here. Yes, it's looking like this. It's broken. Actually, it was supposed to be straight, but it's broken from here. Understood? This is another phenomena of light. Yes, it's a properties of light. What is that property? That property is called refraction of light. So, for the definition of refraction of light, we will write that when a ray of light goes from one medium to another medium. See here, light is traveling from air to glass. Understood? Light is traveling from air to glass. So when light travels from one medium to another medium, then it bends. Understood? It does not go through the same direction. It bends. And that's why you notice that your pen is broken from here. Though it is not broken, but you will notice that it's broken from here. This phenomena is called refraction of light. So what is the definition of refraction of light? When a ray of light is going from one medium to another medium, like here, light is going from air to water, then light bends. Not only air to water, even air to glass, or air to kerosene, or kerosene to glass, or glass to air. Means whenever there is a change in medium, light is traveling from one medium and suddenly it enters another medium, the path of the ray changes. This phenomena of light is called refraction of light. Now we will elaborate it. Say, this is water level. Fine. This is air and this is water. Fine. And this is water level. Now light is going from, say a ray of light is going from air to water. So it is supposed to go straight. But it will not go straight. You will notice that the ray of light will bend this way. Yes. So when a ray of light bends, when it enters another medium, this phenomena of light is called refraction. We already discussed. So this is the drawing of refraction of light. Now if light is going from water to air, say this is water, this is air. Again air, water. Now light is going from water to air. So it is supposed to go straight. But you will notice that it's going like this. Understood? So air to water and water to air. Light behaves in this way. Now this ray is called incident ray. Understood? I repeat. Incident ray. And this ray is called refracted ray. I repeat. Refracted ray. Now, from this point, we'll draw a perpendicular yeah, 90 degree with this surface, this water surface. So this is my perpendicular I am drawing. Fine. And we'll call it normal. So this is my normal. Fine. And this is my incident ray. And this is my refracted ray. Okay. Now, you can see there is an angle between incident ray and normal. Which angle is that? The angle between incident ray and normal. I mean this angle. Incident ray and normal. Fine. And another angle, the angle between refracted ray and normal. This is refracted ray and this is normal. So this is the angle. Fine. This is called angle of incidence and this is called angle of refraction. Okay. Angle of incidence and angle of refraction. Now, there are two laws of, two laws of refraction. So what are those laws? The first law is incident ray, this is incident ray, this is refracted ray and normal all lie on the same plane. What is the same plane here? This board, this white board you can see. All the rays I have drawn on the board. Yeah, this incident ray also on the board. The refracted ray is also on this white board and the normal is also drawn on the white board. So incident ray, refracted ray and normal all lie on the same plane. This is first law of refraction. Now what is the second law? Second law is from trigonometry we know sine, cos, tan, cot, sec, cosec. Yes, we know that. Just we have to take sine of that. We have to take sine of angle of incidence. Sine of angle of incidence. And we have to take sine of angle of refraction. R is the angle of refraction. Angle of refraction. Okay. So first you are taking sine of angle of incidence. Then you are taking sine of angle of refraction. Now if you divide it, like if you find the ratio of this, then ratio is constant. Okay. This is the second law. So according to second law, sine of angle of incidence to sine of angle of refraction. I mean the ratio of sine of angle of incidence to sine of angle of refraction is constant. Understood? This is the second law. So let us repeat both the laws. What is the first law? Incident ray, refracted ray and normal all lie on the same plane. What is the same plane here? This white board. And second law, sine of angle of incidence to sine of angle of refraction. The ratio is constant. So both the laws are done. So as we have seen, sine of angle of incidence to sine of angle of refraction, I mean their ratio is constant. Fine, that ratio is fixed, it's constant. Now this constant has given a special name. Yes, this constant has a special name. That special name is called refractive index. Don't forget, it's called refractive index. Now it has got a special symbol. We call it mu. That special symbol is mu. This is that special symbol, mu. Yes. So mu is refractive index. Fine. Now if I ask you what is the definition of refractive index, then you will say that refractive index is a ratio between sine of angle of incidence to sine of angle of refraction. Okay. Now what is its unit? No, it does not have any unit because refractive index is a ratio. So as we have seen that when a ray of light goes from air to water, let me draw it. This is air, this is water. Fine. When a ray of light goes from air to water, this is my normal. Fine. You will see that when light goes from air to water, the ray of light bends towards the normal. Yes, it comes towards the normal like this. Actually, it is supposed to go this way, but it is not going that way. It will bend this way. Understood? It's coming towards normal. But when a ray of light goes from water to air, like this is the ray going water to air, and this is my normal, it will go away the normal. Yes, it will go away the normal like this. Actually, it was supposed to go this way, but it will go this way. Understood? So here air is rarer medium and water is denser medium. So when a ray of light goes from a rarer medium to a denser medium, understood? Rarer medium to a denser medium, it will come towards normal. Fine. It will come towards normal. But when a ray of light goes from denser to rarer, like here, denser to rarer. So when it will go denser to rarer, it will go away the normal. Away the normal. Understood? And we have also seen that refractive index. What is that? This is a medium, say A, this is W, air, water. Now light is going from air to water. This is normal and it moves towards normal. Fine. And this is called angle of incidence and this is called angle of refraction. And what we have discussed, that sine of angle of incidence by sine of angle of refraction is refractive index. What is the name of this symbol? Mu. Mu is the symbol of refractive index. Now you have to write something here. Understood? Just you have to see from which medium light is going to which medium. Yeah, from which medium light is coming? Here light is coming from air. So you will write here A. I mean air. Which medium light is entering? Water. So you will write here W. Understood? So we have to give the symbols here. A, W. That means light is going from air to water. But when we will say this, we will say this is refractive index of water with respect to air. Yes, while saying this, we have to say in this way, refractive index of water with respect to air. Understood? Now if I discuss in some other way, like say this is medium X, this is medium Y. Light is going from X to Y. Fine. So how this refractive index has to be written? Refractive index, from which medium light is coming? X. So I'll write here X. Which medium light is going? That is Y. So I will write Y. But how to say this? We will say it refractive index of Y. Refractive index of Y with respect to X. Understood? In this way we have to pronounce it. Understood? Now let's say there is a glass slab. Fine. It's a glass slab, rectangular piece of glass. Fine. Now light is going from air to glass. Fine. When light is going from air to glass, so it is going from rarer to denser medium. So light will come towards normal. Yes, see, light is coming towards normal. Fine. So for this portion, I can write refractive index from which medium light is coming? Air. Which medium light is going? Glass. So we'll write AG. Fine. But we'll tell it this is refractive index of glass with respect to air. Fine. Now here light is going from glass to air. So this is my normal. Light is going from glass to air. So it will go away the normal. Away the normal it's going. Fine. So for this case, refractive index is from which medium light is coming? From glass. Which medium light is going? Air. So glass to air. So we'll write here glass, air. Understood? So we saw that when light is going from air to glass, the ray is coming towards normal. When light is going from glass to air, it's going away the normal. Understood? Now we got both the refractive indices. Fine. Now if you multiply them, if you multiply it, the answer will be always 1. So we can write that this into this equal to 1. Now one more case we'll see. Say this is air, this is water, kerosene, and again this is air. Understood? So light is going from air to water, water to kerosene, kerosene to air. Understood? So first light is going from air to water. So for this case, what can I write? Refractive index of air to water. So air to water. But we'll tell it refractive index of water with respect to air into here water to kerosene. So water to kerosene. Fine. Now for this case, kerosene to air into kerosene to air is 1. Yes, 1. But the condition is the first medium and the last medium has to be same. Fine. The rule which I told you that the refractive indices, if you multiply them, you will get 1. But this is true only when first and last medium has to be same. Here first medium is air, last medium is also air. Understood? Now let us solve a numerical based on this theory. This numerical is very important for your exam. See the numerical. The refractive index of water is 4/3. Refractive index of water. So it's given that refractive index of water is 4/3. Fine. And refractive index of glass is given 3/2. So refractive index of glass is 3/2. Understood? What is the refractive index of glass with respect to water, and what is the refractive index of water with respect to glass? We have to find. What do you have to find? We have to find refractive index of glass with respect to water. We have to find this, and refractive index of water with respect to glass. We need to find these two data. But see these two lines. In the first line, refractive index of water with respect to which medium? That is not given. Understood? Refractive index of water is given, but refractive index of water with respect to which medium? It's not given. When the medium is not given, we'll consider it as vacuum. Understood? Vacuum, or you can consider it as air. So we'll write it air. In the next line, the refractive index of glass is given. With respect to which medium? It's not given. So we'll consider it air. Correct. So air. So now see this question. In total, how many mediums are there? Yes, there are 3 mediums. These are air, glass, water. Understood? So we'll consider this diagram. First of all, air, glass, water, air. What is the formula? Refractive index of air to glass is going. So air to glass. Fine. Now here light is going from glass to water. So refractive index, this is glass, this is water. Here light is going from water to air. Okay. So we'll write water, air. Fine. And as we know, if we multiply them, we'll get 1. Understood? Now, this is refractive index of glass with respect to air. It's given. Refractive index of glass with respect to air, 3/2. So we'll write 3/2 into. This is refractive index of water with respect to glass. We have to find it. So just write this into. This is refractive index of air with respect to water. The value, see the value? The refractive index of water is given with respect to air. See this, refractive index of water with respect to air, it's given 4/3. But here it is refractive index of air with respect to water. This value is not given. So what we'll do? See, this is A mu W, but this is W mu A. So just opposite of that. So that is 4/3. So we'll write here 3/4. Fine. Equal to 1. Understood? So we'll calculate it here. Now, so 3 is the 9. 9 by 2 4 is the 8 into G. Understood this equation? So G mu W equal to this 8 into 1, 8, 9 down. So 8/9 we are getting. Understood? So we got the refractive index of water with respect to glass is 8/9. So we got this value, this one. We got it 8/9. So we got refractive index of water with respect to glass is 8/9. Now what is the refractive index of glass with respect to water? I mean just opposite. Because this is G mu W is 8/9. So what is W mu G? Just opposite of that. Yeah, 9/8. So this is 9/8. Understood? In this way we can find out the refractive index of glass with respect to water or refractive index of water with respect to glass. Just one thing you have to remember, like in this question, the refractive index of water was given, but with respect to which medium? That was not given. So when that thing is missing, we'll write air. So as we have seen, say this is air, this is glass. Fine. Rarer medium, denser medium. So when light is going from rarer medium to denser medium, the ray will come towards normal. So it's coming towards normal. Understood? This is angle of incidence, this is angle of refraction. And we know that this refractive index, from which medium light is coming? Air. Which medium light is entering? Glass. So we'll write AG. So this is refractive index of glass with respect to air, equal to sine I by sine R. Fine. This is the formula of refractive index. But there is one more formula of refractive index. What is that formula? We can also write that speed of light. Yes, the speed of light in, from which medium light is coming? From air it is coming. So we'll write air. Speed of light in air by which medium light is entering? Glass. So we'll write speed of light in glass. Understood? So you have to also know this formula. Fine. Now let us solve this numerical which is displaying on your screen. What is that numerical? the speed of light in air is 3 into 10 to the power 8 meter per second. What is the speed of light in glass? And what is given in the bracket? Refractive index of glass is 3 by 2. Refractive index of glass is 3 by 2. How to write that? Refractive index of glass is 3 by 2. But refractive index of glass with respect to which medium? That is not mentioned in the question. So which medium it should be? Air. So we'll write air. Understood? Now we know the formula of this. What is the formula of refractive index related to the speed of light? Yes, we should write that formula first. So speed of light in air by speed of light in glass equal to 3 by 2. Now in the question, the speed of light in air is given. What is that? 3 into 10 to the power 8. 3 into 10 to the power 8 by, what is the speed of light in glass? Say x. Fine. Equal to 3 by 2. Now cross multiply it. What we are getting? 3 into x, 3x equal to 2 into this, 2 3 just 6 into 10 to the power 8. So x equal to 3 2 ja. So 2 into 10 to the power 8 meter per second. So 2 into 10 to the power 8 meter per second. This is the speed of light in glass. So in the whole session, what we discussed what is called refraction of light. Then we discussed what is called refractive index. And remember, refractive index does not have any unit. Why? Because it's just a ratio. And after that we saw that refractive index is equal to sin I by sin R. What is I? Angle of incidence. What is R? Angle of refraction. And after that we saw that how to find the speed of light in any medium by using refractive index. So both the formula you have to remember, and we'll see few more topics and numericals related to this chapter, refraction of light, in our next video. I hope you understood this. Thank you.